Yeah, in the next exercise we will do many more exercise. So in this exercise limit, we want to find the limit x approaches to 0 and sine hyperbolic x divided by x raised to the power 1 divided by x square. Okay, so we want to find the limit by using the L'Hopital rule. So how we apply the L'Hopital rule? What is the method to apply the L'Hopital rule? We actually apply the L'Hopital rule when it is 0 divided by 0 form. So in order to remove this indeterminate form, which is also called 0 divided by 0 form, we use the L'Hopital rule. So to find the limit of this function, what we will do? So suppose if I put the direct limit, and before putting the direct limit, let we suppose that y is equal to sine hyperbolic x divided by x and raised to the power 1 divided by x square. Okay, so taking natural log on both side, it is sine hyperbolic x divided by x raised to the power 1 divided by x square. So by the property of log, we can write the exponent 1 divided by x square before log, means we can write 1 over x square over here. So natural log of sine hyperbolic x divided by x. Okay, and we can also write this expression just like natural log of sine hyperbolic x divided by x and x square. Okay, our limit is obvious. What is the limit? The limit is x approaches to 0. It is obvious. I'm not writing with it is obvious. So okay, now what we will do, which it is form. Suppose we apply the limit, then what it will be the form. Okay, it is natural log of 1, because when we apply the limit, sine x divided by x, sine hyperbolic x divided by x is 1, and natural log of 0 is also, natural log of 1 is 0, and divided by x square, and since the limit is approaching to x approaches to 0, so it is 0 divided by 0 form. So this means that we can also write the limit. Okay, I'm writing the limit over here. It is the limit is x approaches to, it is equal to limit x approaches to 0, and here limit x approaches to 0. Okay, now it is 0 divided by 0 form. Since it is 0 divided by 0 form, why it is 0 divided by 0 form? Because natural log of 1, this is equal to 1. When we take the limit of this x approach to 0 by the formula, this is equal to 1. So natural log of 1 is 0, and also since x square, and when we put the limit over here on x square, this means that we will get 0 divided by 0 form. So in order to remove this difficulty, 0 divided by 0 form, it is also called indeterminate form, what we will do? We will use the L'Hopital rule. So what is the L'Hopital rule? We take the derivative of the denominator term and derivative of the numerator term. Okay, so now take the derivative of the numerator and denominator term. So before taking the derivative, we can write it is just like limit limit x approaches to 0, natural log of sine hyperbolic x, natural log of sine hyperbolic x minus natural log of x by the property of log divided by x square. Okay, x square. Now we apply the which form? L'Hopital hospital rule. Take the derivative of the numerator terms and denominator terms. The derivative of natural log of sine hyperbolic x, it is limit x approaches to 0, and the derivative of natural log of sine hyperbolic x is 1 over cos hyperbolic x, and the derivative of sine hyperbolic x is cos hyperbolic x. Okay, and minus the derivative of natural log of x, it is 1 over x, and also take the derivative of the denominator term, which is x square only, and it is 2x. So after taking the LCM, what we get? It is equal to limit x approaches to 0. So what is the derivative of x approaches to, it is limit x approaches to 0. So what is the derivative of we take the derivative, and cos hyperbolic x divided by this was cos, this was not cos, it was sine, because sine hyperbolic x, okay. So after taking LCM, sine hyperbolic x and this x will be shift into the denominator. So our x, it will be x cos hyperbolic x and minus sine hyperbolic x divided by 2x square sine hyperbolic x. Okay, now we again check it. Either it is 0 divided by 0 form, either it is determinate form, or it is not. If it is indeterminate form, means 0 divided by 0 form, which means that we will again apply the L'Hopital hospital rule. So limit x approaches to 0, okay, this term x approaches to 0, it will convert into 0, and of course this is again 0, so 0 minus 0 is 0. When we apply the limit over here, x approaches to 0, again 0. So this means that it is again 0 divided by 0 form. So if it is 0 divided by 0 form, what we will do? 0 divided by 0 form, what we will do? It means that we will take the derivatives of the numerator terms and denominator terms. So take the derivative of the numerator and denominator term. I'm taking the derivatives, which is equal to limit x approaches to 0. So the derivative of x cos hyperbolic x, what it will be? It will be cos hyperbolic x and plus x sine hyperbolic x and minus cos hyperbolic x divided by, what is the derivative of 2x square? It is 4x sine hyperbolic x plus 2x square as it is, and derivative of sine hyperbolic x is cos hyperbolic x. Okay, now cos hyperbolic x is cancelled out with cos hyperbolic x, and this will be equal to x limit x approaches to 0, it is x sine hyperbolic x divided by the term as you see. Okay, so see over here, either it is 0 divided by 0 form or not. I'm seeing that it is again 0 divided by 0 form. So I am writing it in the above. Remember that what are the terms? Since our page has finished, what are the terms? and the numerator term is only one term, x sine hyperbolic x, and in the denominator there are two terms. The first term is 4x sine hyperbolic x, and the second term is 2x square cos hyperbolic x. These two terms. I'm clearing this page. Before clearing this page, let's take a little look of the question. Okay, so only two terms we write, x sine hyperbolic x, and in the numerator one term, and in the denominator there are two terms, 4x sine hyperbolic x plus 2x square cos hyperbolic x. These two terms will be written. Okay, I'm going to clear this page. Okay, now what are those terms? The terms are equal to limit, and this is the limit x approaches to 0, and in the sine hyperbolic x, and the second term in the denominator there are two terms. The first term is 4 sine hyperbolic x and plus 2x cos hyperbolic x. So now we check that either it is 0 divided by 0 form or it is indeterminate form. Yeah, when we put limit x approach to 0 over here, then what does it mean by it? Means that sine hyperbolic 0 means 0. So here 4 sine hyperbolic again 0 plus it is 1, but when multiply with the x, okay, over here it is again 0. Okay, so 0 plus 0, 0 means this is 0 divided by 0 form. If it is 0 divided by 0 form, then it means that we will again apply the L'Hopital rule. We will apply the L'Hopital rule up to that when it will not be in indeterminate form. So again take the derivative, limit x approaches to 0. Sine hyperbolic x is equal to cos hyperbolic x divided by 4 cos hyperbolic x. It will be 4 cos hyperbolic x, and the derivative of 2x cos hyperbolic x is plus 2 cos hyperbolic x plus 2x sine hyperbolic x. Okay, so now we check that now it is not indeterminate form, because when we put the limit over here, it is 1, and this is 0. So this approach to 1, and when x approach to 0, this will be 1, and when multiply by 4, okay, this will be again 1, and this is 0. So this means that it is not in indeterminate form. It is not 0 divided by 0 form. Therefore, after applying the limit, what we get in the denominator we get 0, numerator we get 1 divided by 4 plus 2 plus 0, which is equal to 1 divided by 6. Since we take the natural log, so natural log of y is equal to 1 divided by 6, and y is equal to e raised to the power 1 by 6 is our answer. Okay, take a look.